right, so we're going to do some parallel line proofs. I went ahead and wrote in my givens. It is always a good idea to mark them in your picture so we know that line A and line B are parallel. And we know that angle 2 and angle 3 are congruent. And what we're trying to show is that angle 1 is congruent to angle 3. Okay, so if you think about what we get from the fact that those two lines are parallel to each other and the angles in our picture, that would mean that angle 1 and angle 2 would have to be congruent because they are alternate interior angles. So let's jot that down. I'm going to do THM for theorem. I don't know if you guys put that or not, but I'm going to. And then if you look at where we're at now, we're trying to get that 1 is congruent to 3. So if you put these two steps, 2 and 3, together up here, since 2 is congruent to 3 and 2 is congruent to 1, we can use the transitive property to say that angle 1 is congruent to angle 3, and then we will have what we need. Let's take a look at 3. So we're given that angle 1 is congruent to angle 7. So this angle up here, this angle down here, congruent. We're trying to prove that angle 4 is congruent to angle 8. So 4 and 8, if you look at their relationship, those are corresponding angles. So if we were able to show that L and M are parallel, we would be able to say that 4 and 8 were congruent. So let's think about the fact that angle 1 is congruent to angle 7. Those are alternate exterior angles, which, if they're congruent, is going to mean our lines are parallel. So we can go ahead and say that line L is parallel to line M by the alternate exterior angles theorem. And then once we've said that those are parallel, we get all the angle relationships that are guaranteed, including that angle 4 is congruent to angle 8 because those are corresponding angles. Takes longer to write this down than it does to actually talk through it. Okay, so there's a couple. Let's move on to some more complicated ones. Here we've got line C is parallel to line D, and angle 1 is congruent to angle 7. We're trying to prove that the other pair of lines, A and B, are parallel to each other. So anytime you're trying to prove that two lines are parallel, it is a good idea to see if you can get any of your angle relationships figured out that would ensure that those two lines are parallel. So let's get either angle 1 or angle 7 involved here, because those are the ones that I was given. Let's just go with, there's lots of ways you can do these. So if you pick a different method, doesn't mean you're wrong. Let's go with angle 3 and angle 1, since I already know something about angle 1, are congruent because those are corresponding angles. So along transversal A, since C and D are parallel, we get our corresponding angles. 1 and 3 are congruent. Okay, now the reason I picked 1 and 3 to put down in my list of information here, even though I had a bunch of other true facts I could have put, is because I already had 1 being congruent to 7. So if 1 is also congruent to 3, I can put those previous two statements together to say that angle 3 is congruent to angle 7 by the transitive property. And now if angle 3 and angle 7 are congruent to each other, then along transversal D, those are corresponding angles, and that will guarantee that line A is parallel to line B by the corresponding angles converse. Remember that when you're trying to prove that two lines are parallel, you have to use your converse of your original theorems. All right, we've got a couple of parallel lines. Line AB is parallel to line CD. We know a couple of congruent angles, measure of angle ABC, so that one up there, and ADC down there are congruent. And we are trying to show that line AD is parallel to line BC. So again, our goal is to get either some corresponding angles congruent, alternate interior angles congruent, some sort of pair of angles that have our required relationship to show that those lines AD and BC are parallel. Okay, so let's look at what we get. We already know, since line AB and DC are parallel, that this angle here, BCD, and one of my angles I was given information about, ABC, should be supplementary because they are same side, sorry, I think you guys call that consecutive interior angles. So let's go ahead and jot that down. So angle ABC and angle BCD are supplementary. If you're like, why did you pick that to write down as opposed to like the other two, ABAD and ADC, wow, being supplementary? It doesn't really matter. You could have picked the other two to write down and you would get there. The thing about proofs is that there's a ton of different ways that you could do them. So just because you don't do it this way doesn't mean that you're wrong. So that's by consecutive interior angles. All right, let's go ahead and write down the equation that gives us. So if they're supplementary, I know that their measures are going to add up to 180 degrees. And that'd be definition of supplementary angles. All right, now that I've got my equation written, if you look up in step 2, the measure of angle ABC is equal to the measure of angle ADC. So I'm going to go ahead and replace measure of angle ABC in my equation down here with the measure of angle ADC, since they're equal. So those two are going to add up to 180. And if you look at where those are at in our picture, ADC is right here, and then BCD is right here. So the reason that making that substitution, which should be my reason right here, reason that making that substitution was useful is that those two angles for lines AD and BC are consecutive interior angles. So if they're supplementary, that's going to prove my two lines are parallel. So let's go ahead and write down the fact that that has shown us that ADC and angle BCD are supplements, because that's what the definition of supplementary angles is. And then we can use, like I said, the fact that those are consecutive interior angles to go ahead and say that line AD and line BC are parallel. And again, don't forget that you would need to use your converse because we are using that angle relationship to say that the lines are parallel. All right, there's a lot of lines in this picture. So let's label what we've got. Angle 15 and 16 are supplements. Oh, sorry. Angle 5 and angle 16 are supplements. Those two. And angle 2 is congruent to angle 18. Okay. So let's take those pieces of information one at a time. So looking at your 5 and 16, if those are supplementary, think about lines P and Q. Those are same side consecutive exterior angles. So that would mean that line P is parallel to line Q by the consecutive exterior angles converse. It's always a good idea to get any lines stated as parallel that you can, because then you get a lot of angle relationships. Okay, so we used fact number 1 to say that those two lines are parallel. Angle 2 is congruent to angle 18 is going to tell us, if you look at a different pair of lines, so the transversal and two lines involved there are in pink. 2 and 18 are corresponding angles along transversal S for lines P and R. So if they're congruent, that's going to tell us that line P is parallel to line R by the corresponding angles converse. And once you've got those two facts in 3 and 4, if P is parallel to Q and P is parallel to R, we can go ahead and say that Q and R are parallel to each other by the transitive property of parallel lines. So for this one, we've got angle 1 and angle 7 being supplementary. So that is these two. And we're supposed to prove that line A is parallel to line B. Okay, so let's use the fact that angle 1 and angle 2 are supplementary to go ahead and write an equation that says that their measures add up to 180. Okay, now we've got to get some other angles involved here that are related to either angle 1 or angle 7. So even if we don't know these lines are parallel, we do know that angle 1 and angle 6, since they're vertical. So let's go ahead and say that angle 1 is congruent to angle 6 because they're vertical angles. And then that's going to allow us in a second to replace angle 1 with measure of angle 6. And then I'll have a statement that should allow me to say that my two lines are parallel. So let's go ahead and do measure of angle 1 equals measure of angle 6 by definition of congruence. We're going to replace measure of angle 1 with measure of angle 6. By the substitution property. And then if you look at what we've got that angle 6 and angle 7 up here are supplementary angles, which means since they are consecutive interior angles, we're going to be able to say that line A is parallel to line B. So let's go ahead and say that angle 6 and angle 7 are supplements by the definition of supplementary. And then A is parallel to B. Well, it's line B by the consecutive interior angles converse.